And tonight, Jason did ask, or Scott, or they both asked about F#. I started as an F# MVP before they sort of retired the language specifications. I've also been a data plat, an AI MVP for Microsoft, but
is that technically developer technologies or something like that?
I think it is now. I sort of lose track. I don't pay enough attention to those things, maybe. I think it's sort of grown, because I've been working at a big company for long enough that you always get a boss every 6 months when they restructure. So I sort of forget their names now. Yeah, so it's the language platform. And so I thought I'd talk about F#. And to answer your question, I think it was Scott, JetBrains does in fact have F# support through JetBrains Writer. It's a really nice IDE experience. But hopefully by the end of this talk, one of the things I hope to convince you is that F# is very minimalistic. You really don't need an IDE or really don't need a fancy one. And you certainly don't need a lot of the component libraries and all those sort of add-ons that you do for perhaps some other languages. I'm looking at you, Java. So, the choice of the IDE, most people in the F# world use Visual Studio Code with one plugin, and they're quite productive. So it's a really nice feature of the language, and I hope to illustrate that tonight. In addition, even at 7 o'clock when we're all done and everyone's drinking their favorite beverage, I hope to convince some of you to maybe take a look at F# and start using it, and maybe you'll grow to love it the way I have. But if not, it still should positively impact how you write your C++ code, because I'll emphasize functional software language design and implementation. So of the three major ways of looking at software: imperative code, object-oriented code, and functional code. C++, I'm guessing you're all very much steeped in the object-oriented and imperative side. Hopefully, at the end of this, you'll look at the functional side a little bit more and critically, and maybe it'll make you a little bit more productive. So those are my two big goals. Any questions about where I'm coming from, where I'm going, what we're going to do? And yeah, feel free to speak up. If you don't feel comfortable speaking, go ahead and hit the chat. And Jason agreed to be the wingman tonight. Just type it in there, and then he can interrupt me. And I'll pause frequently because, like new things, like a new language, might be overwhelming at times. So I'm happy to go as slow as any person wants. And we'll leave it at that. So yeah, so that's the title of the talk. One of the things I learned about speaking is you always want to get the audience on your side. And so instead of telling a joke, I thought I'd just put on some clickbait that I saw on Twitter about 3 weeks ago, that Microsoft's abandoning C++ and going to Rust. And if you believe everyone, and Microsoft did some F# work, but they don't have tons of it. Apparently everyone on this call, C++ and F# people, we should all be learning Rust. Obviously it was clickbait, and obviously it was designed to get hits. C++ is a fantastic language. It's a language I first learned on when I got my comp-sci degree. And I don't think that Ryan Levick speaks for all of Microsoft, but he's at all things open, and he's really trying to push Rust, so that's the way he did it. So I don't know. I thought I'd just bring it out there. I don't know if anyone has experience with Rust, or maybe we could do a Rust for the C++ developer later on. So here's the agenda. And there's a bunch of concepts. Most of it is going to focus on the language and the functional concepts themselves. But I wanted to give you some real-world-ish examples of why F# I think is a fantastic language. So I put those at the end. And then I also put a couple arguments about why terse code is, in fact, can be more correct code, and why functional can often be better than object-oriented to solve certain problems. And I hope to highlight that. And it's not really an argument. We'll have a polite discussion. If your mind's made up, I'm not going to change it. But if you're thinking about functional concepts and how it can help you, I hope to illustrate some of the differences and help you along. And that's all I have for slides. So, and if you want to look, this way you can contact me if someone wants to screenshot this right now. But I am on Twitter at Jamie_Dixon. And I'll leave that there for a second more if anyone wants to contact me. If you want to talk F#, you want to talk other languages, you want to talk bioinformatics, my 9-to-5 job, I am an NLP engineer, data scientist, leading a team. My 5-to-9 job is 100% into computational genomics, really steeping myself in that domain. just because that's so fascinating to me, and where the industry is going and how fast it's evolving. They are moving so quickly, and the tools and languages and the paradigms that they're using are so far behind. It's really slowing them down. So it's just an area that I think it's really cool. Like, instead of working on the next phone app, I'm working on DNA samples trying to cure cancer. That's cool stuff. So if anyone's interested in that kind of stuff, definitely hit me up on Twitter. So that's it for PowerPoint. I have 5 Visual Studio solutions. I should ask this right now, maybe just informally, but Jason, is it fair to say that most people use Visual Studio for their C++ work at your company? So,
most.
No.
No, I wouldn't say most people use Visual Studio. We can ask in the room here.
Okay.
But just looking at the people that I know on here, I'm guessing it's maybe about a quarter of the people here use Visual Studio for their work.
Well,
everyone else tends to use Linux, basically.
Oh, really? Yeah, very cool. Yeah, well, I use Visual Studio. Usually I do this talk for C# developers, and they're very much beholden to Visual Studio. C++, you folks are definitely more, you're less tool focused and more language focused, and I think that lends itself actually to really positive things in your community. But I am doing this all in Visual Studio today, and the first concept I wanted to talk about is F# is the functional language for .NET. And if you're not as familiar with .NET as perhaps your C# brethren, it is the runtime, it is the language, it's a runtime that Microsoft rolled out about 22 years ago. They had Anders do a knockup of Java, which they subsequently lost the court case over, to port it to C#. About the same time, they moved VB6 into VB.NET to make those two languages compatible, so you could write something in C# and consume it in VB.NET, vice versa. Then about 10, 12 years ago, they rolled out F#, the functional language we were talking tonight. And because it is .NET, it works perfectly well with C# and VB.NET. So here you see, and I don't know if this is too small, so Jason, let me know if people can't see it, but I have a Visual Studio solution, and in it I have 3 projects. These projects are an F# project, a C# project, and a VB.NET project. We'll start with the C# project, which is a library, so that compiles to a DLL. In there, it's fairly straightforward. I know it's not pure C++, folks. This will look very familiar to you or comforting to you, right? We got our class called CS Worker. We have our static void main run entry point. We write out to standard output that this run was invoked, and then we go ahead and sleep for 3 seconds. That's the sum total of what this DLL does. I then created another class library in VB.NET that does exactly the same, except it says VBWorker.run, but it's the same kind of thing. You got a class called VBWorker, you have your entry point, which is called sub, because in VB they have subs and functions. Subs don't return anything. It drives me up a wall. But anyway, we write to the standard output, we sleep for 3 seconds. Meanwhile, I wrote an F# app. And this F# app is actually a console application. So this one went ahead and added a reference to my C# app, my VB.NET app, and I said, okay, go ahead and import those in. I'll talk about the syntax in a second, but I think it's pretty intuitive of what's going on. Import those libraries in, go ahead and write out to common output, I'm starting. I then start my CS worker, I start my VB.NET work, and then I run to the output. And again, the static void main is not there in F#. Any function could actually be my entry point. I just have to tag it with this attribute called entry point. So if I go ahead and run this, the compiler is going to whir, it's going to clink, and then it's going to head and spin up a console window for me, or I hope it does. I didn't have time to make an offering to the presentation gods, so, oh yeah. So you can see that they invoked, and then we're done. So the reason I want to lead off with this is that if you happen to be in a C# and a VB.NET shop and you are curious about F#, it's not a one or the other type situation. You can spin up a project on your latest, whatever your sprint is doing or whatever your next release is doing and your next feature you want to add is. And you can build it in F#, consume it in your C#, your core libraries, and everything sort of worked. And this is actually the way I sort of did it, is I started migrating code per release, per feature over to F# from my C# libraries. And it was pretty effective, and it definitely had some benefits as I did it. But so I just wanted to sort of point that out and show that. Granted, you're all C++ developers on managed code versus managed code. You actually can consume C++ as an unmanaged if you add some attributes into that library. But I don't, in my 8 years of using F#, I've never done that, so I can't speak to how well that would actually work.
I have a question, if you don't mind. On the C# and VB projects, I saw that those functions said 0 references highlighted above it, which looked like a resharper. Is that resharper, or is that Visual Studio doing that, or is that, I mean, is that a plugin, or is that Visual Studio? Do you know?
So that is Visual Studio. This is Visual Studio 2017, I think. Yes, 2020. They're due for another refresh this year.
Right.
Yeah. One of the things you'll find in in the F# world is that you really don't use a resharper anymore. I mean, we have a linter, but that's it. It lints and that's it. There's the code. I'll come to it, but there's so much less code. It's such a terse language that, and the functional way of writing code is such that not only is the language very terse, but your models and the way you're sort of abstracting all these ideas compact very quickly. So you don't really have this fan-out problem of these really complex object graphs. And I'll hope to illustrate that in a little bit with some real-world examples. So we really don't use, F# community really doesn't use resharper. We don't really use JetBrains plugins. We have an IDE and we write our code and it works.
Okay.
Was that too long of an answer, by the way? I don't know.
Not at all. Not from my perspective.
All right. Yeah, I try to, I know we're limited on time, but I try to give you the best answer I could. So let's start with, oh no, that's concept one, my bad. This is a Visual Studio solution. In it is a Visual Studio project.
I think we might be seeing the wrong display, Jamie.
Oh, you didn't see yourself? Okay, let me start sharing the other thing.
I saw a 4:3 display, not the widescreen one you had up earlier. I don't know.
The problem is, yeah, I have the same background on both screens. So.
You're right.
You got it.
Yeah, it was just the resolution that made me go, wait a minute. Okay, yeah, we're good.
How about that?
You're good.
All right, we can't go any worse, so let's make it better. Okay, so Visual Studio Solution, Visual Studio Project in F#. The first thing I want to point out, unlike the prior example where we compiled code and we ran it as well, there were 2 DLLs that were linked into an executable running on Windows. This is a Visual Studio project with a bunch of script files. Because F# at its birth was 100% open source and 100% designed to be both a scripting and a compilable language. So because of that, most of the work that F# people do when they're proving out ideas or demonstrating, we don't actually stand up an executable project. We don't do standard output. We don't do any of that. We use this thing called a REPL, which stands for Read, Evaluate, Print, Loop. And the idea of a REPL is that you type some things, you have it evaluated, it prints out, oh, there's my results, and then I go back again, and I keep looping like that. And so it's a very efficient way to prove out concepts. Jason, does my screen look okay? Does that look big enough for people to read as I go through this code?
From my perspective, it looks good. I don't see anyone complaining in the chat.
Okay, so I don't type in front of people because I suck at typing, which is why I got into software. So I will just go along each line and highlight either single lines or blocks, and we can move on from there. On the left, you see the line numbers. So I was on line 6, for example, and I said, oh yeah, this is a code comment. Double wax. It's the same way you do in C++. You guys have double wax, right, for code comments? Still? It's been a while.
Yes.
Yeah. One thing you'll miss is there are no semicolons. And in fact, we don't even use curly braces. So much like Python, if you've seen that before, white space becomes important. The way we organize our code with blocks actually defines how the functions are created. And then the programs are just collections of functions. And I'm going to show you that as we go. But if you're looking for semicolons, if you're looking for white space, or you're looking or curly braces, if you're looking for like sort of this noise that has nothing to do with actually solving your problem, but it's really just language syntax, there's very little. And for me, that was really disconcerting because I wanted to see semicolons. I wanted to see curly braces. I kept hitting semicolons even though they weren't needed for about 2.5 years. I'm serious. So, and that's one of the, semicolons don't add a lot of code clutter. Curly braces certainly can, particularly when you start nesting things. But I'll show you all that as we go along. Now, lines 13 to 15 should look incredibly familiar to you, where I'm declaring an integer called my number. On line 14, I'm setting that integer to 1, and then I'm sending it to standard output. This is valid C++ code, or at least that was what I was told when I went to Wikipedia to look up the values. So, Jason, does that compile? Would that work?
Well, not by itself. You may have to have an include file and some other things, but yes.
Okay, but that block itself.
Yes.
So one of the things, and I know that this is a primitive type, not a native type, like we're doing integers versus ref types. But one of the things that I learned, or one of the benefits I got from F# almost immediately, was that we cannot have nulls. We cannot have null ref exceptions. And if you ask, who wrote C++ Strustrep, right?
Yeah.
And he said that nulls was his biggest mistake, I think it was. If he didn't allow nulls, it would have wiped out about 40% of the errors that he sees in the language. I think that was him, or maybe it was.
I think that was. Yeah, I don't think that was Strustrup. Yeah, but that's all right.
Yeah, so someone who designs languages that allows nulls, later regretted it. But in any event, when you create a value, not a variable in F#, you have to assign the value. You have to assign it at right away. So for example, lines 19 and 20, let is my keyword to assign something. So in this case, we have let my number, and then I tried to say, I'm not assigning any value to it until line 20. Well, you can see the red squiggly line of approbation right here. It's not going to let me do that. You have to do it like on line 23, which is my first language syntax for you. Let my number equals 1. You have to have a right-hand side. You cannot save it. You can't declare it and not point to anything. You can't have a dangling reference. You can't have a null reference. You can't have a pointer not pointing to anything yet. Now in C++, you all are super jocks in the world. So no one has memory allocation issues or anything like that. I had tons when I was doing C++ in my undergraduate days. But C#, this happens all over the place, where they'll declare a variable, they'll forget to assign it, or they'll assign it later on, but something happens before then and the computer goes boom. Once I got over the frustration of always having to declare things first, it became it was like the guardrails came in, and it allowed me to concentrate on other things than worrying about if I have a reference or that I don't allocate or deallocate memory. So let my number equal 1 creates a value of 1. And the other cool thing about F# is that it is an inferred typed language. Right? We have a type system. We use reference types. We have customers. We have objects, blah, 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 blah. In addition, we don't have to declare them ahead of time because the interpreter can figure it out for us. So I don't have to type, in 32, my number. I'm just going to say, let my number equal 1. And then the interpreter or the compiler figures out that, oh, he must be 1. That must be an int. And so, yeah, if I highlight this and run it, and I'm running this by hitting Control-Enter, or Alt-Enter, excuse me. And you can see this F# interaction down below. That's the results of every line of code I run. That's part of the REPL, read, evaluate, print. That's the print, and then we loop back. You can see that it says, okay, I've got a value type of my number, and it's an integer, and it equals number 1. It's almost like I've created a synonym. My number and 1 are now inevitably joined. And if I run the next line, which is line 24, and I hit Alt-Enter, it's going to tell me a whole bunch of stuff about int32, because that's the type it is.
We have a couple of questions coming in. Since you're focusing on int here, because notice the highlight over there, it says int. Is int defined to be a 32-bit integer? Do we know that?
So int is an alias, so yeah, it's an int32.
Okay, so it's not platform dependent or anything like that?
No.
Okay, and that's also a comment from a couple of people here saying that this reminds them of MATLAB so far.
MATLAB?
That's what they're saying.
Cool.
It's been 24 years since I looked at MATLAB, so I don't have any opinion.
I call myself a data scientist, engineer. I've never used MATLAB, so if it's MATLAB, something like maybe I'll check it out. I know it's like, wasn't it super expensive?
I think,
Like,
well, I mean, I used university licenses personally,
Yeah.
so.
But like out in industry, like MATLAB is, and I think they've lost ground tons to like Python and R, and maybe SAS is still out there. And I don't know. But yeah. So if MATLAB's like it, that's cool. But unlike a lot of the languages where you can declare something and it becomes an int, like JavaScript, that language from hell, you can't mess with it. So I want to go down to line 28, and I'm going to hit enter. Now, you can see right away, I expected my number to be an integer, and then I tried to pass it in a float because I put in the decimal point. And so it says you can't do that. Also, and some of you probably already know this, but some of you may not have noticed, this equal sign is not an assignment. Because I've already declared my number, and it's an integer, and it's the number 1, it's that forever. There is no mutability allowed. We have to allow cross-plat compatibility with C# and VB.NET, but out of the box, you can't change things. That's a central tenet of functional programming. You favor immutability over mutability. So this is not an expression of assigning 1.0 to my number. It's actually comparing it as a Boolean expression. See, and that's why you're getting this really crazy IntelliSense. So let me come over here to my number equals 2. And of course, I'm going to get false because I'm doing a comparison. You're saying, is my number equal to 2? You can't make my number anything other than 1 forever. Now, there is a keyword called mutable that you can do it. No one uses it in the F# world. The challenge is, can you write an entire application without any mutability? And at the end, I'm going to try to challenge you to write an entire application with no mutability, no if-then statements. I think that was it. Let's just start with those two to first and see how far we go. So the next thing is, if I wanted to create a float, I would do my other number, and sure enough, my other number is a float, and it's equal to 1.0. Okay? The thing I want to highlight after all of this is that it's a value declaration, not a variable. We don't vary anything. Once we assign it, it's immutable. Can't change it forever. And that includes ref types. We'll get to that in a minute. Any questions about the syntax, the let keyword, or the equal sign, or anything I've done so far?
I have a question about the light banding. So can you do this name shadowing like in some other languages allow you to do? Like, can you do let my other number equal to 2.0 afterward?
I think my speaker is not very good. I might have to put my headsets on. You sound a little bit further away.
He said, can you do let my other number equal 2.0? Like, what happens if you try to shadow that value?
Like my other, you just wanted me to type, damn you. So if I try to do that, right? That's what you're asking right there?
Yeah. So it redefined that variable as a new value.
Right.
Okay.
And if I do this, we've already seen that.
And that's a
Boolean
comparison.
expression. If you really want my other number to be there, so if you want it, if this turns you on, I can keep going to this alone, but I can do something like this. Let my other number, and this, if anyone's programmed in R, you'll recognize that character. That means I'm taking a value and I'm shoving it into a mutable variable. See, that's what that character is. But look, this says unexpected symbol left in pattern. What they really should have said is, hey, dummy, that's an immutable variable. You can't change it. But they took out all my code comments in the GitHub pull request to say dummy. So if I really want this to be mutable, oh, sorry. I should have done like this. So I'm going to make this immutable again, and then try to shove in 2.0, and then there you go. The value is not mutable.
Okay.
Right, and so they took out my dummy word. Yeah. So cool. And then yeah, my other number now resolves to 2.0. I really didn't want to bring it up because then you're going to go out and start F# and use mutable, and you shouldn't. Bad. But yeah, that's the way you would do it.
There's also a question here asking what it is actually compiling to. Or
You
is
know,
it compiler?
I don't know. I'm not smart enough, or I don't spend my time in the compiler.
Okay.
I don't know what the intermediate. So C#, F#, VB.NET, it goes through the compiler and it gets compiled to something called Missile or Microsoft Intermediate Language.
Right.
And then from that, it goes down to the binaries. When you look at the Missile, I haven't looked at Missile in years. So
That was the question. So it is going to Missile, basically.
oh yeah, yeah, it is. And if you
Okay.
compare them, there's two different compilers, the F# compiler and then the Roslyn C# VB.NET compiler. They do things slightly differently. So if you look at, well, maybe line 34, 33 and 34 would look exactly the same if you follow the opcodes and everything. But once you start building things for real, I think they do very much differently implementations. But I'm not a compiler guy, so that would be something you could ask on the F# group.
There's one last comment here that APL uses the same syntax for assignment of mutable values.
Well, and yeah, and if some people are interested, the history of F#, I mean, this wasn't, you know, Don Syme out in Microsoft Research just sitting on a rock one day. He loved OCaml. So if anyone's no Camel fan, this is pretty much OCaml with a .NET compatibility and runtime. Cool on number one? So
Does
now
it let you
Go ahead.
specify the types like is happening in these error messages?
there is a way to specify the type that I'll show you in functions. So if the compiler can't infer the type, you have to specify it, and you have to do it in certain circumstances. Does that answer your question?
Yeah.
Okay. I'll show you that in this next one, if you don't mind waiting on that one, as I lift my leg up and put more cloth on it. Good?
That's because Jamie is bleeding from an accident that he had earlier today, for those of you who joined late.
The rule is don't buy an old house. If you do, don't fix it yourself. But I hear, you know, since, never mind, I'm not going to make jokes, I should. So I'm going to read a little bit to you. So we already discussed that functions are, we already discussed the let keyword. Well, you'll find out when you do functional programming that that functions and data and your assignments are all pretty much the same thing. So when we declare a function, we also use the let keyword. So I'm going to come down here. And this is an example of my function. My function has one parameter, two parameters, and returns the addition of those two parameters. So I'm going to take my cursor and hover over my function to let IntelliSense do its magic. Notice that parameter 1 is an integer, parameter 2 is an integer, and the return value is an integer. The compiler figured all that out by inferring everything. When it first encounters things like this, it assumes it's an integer. I can make this a float. We'll show you that in a second. But I want to point out a couple things. Terseness. This function is incredibly compact. Not a single character is wasted, right? There's no curly braces, there's no semicolons, there's no return keyword. You have probably the least amount of code that you can to actually declare a function with two parameters and return the output. Notice that there is white space here. If I go like this, I'm going to go backspace 4 characters. Don't judge me on tabs versus spaces. You'll see that it doesn't compile anymore. However, if I do this and make it a single line function, it's happy. So when you go to the second line, you don't need your curly braces or anything. Tab or space on in, and you're good to go. Very much, or exactly like Python, if you've been doing some Python programming. So hovering over this again, I want to point out one other thing. We'll talk about it more about partial application, but this function actually only has one parameter, even though you think there's two parameters. And getting my head around this is still tricky sometimes when I see some really advanced functional concepts. But basically, my function in parameter 1 is turned into a sub-function by the compiler underneath the scenes. And then parameter 2 is passed into that sub-function with parameter 1 already baked in. So in the functional world, there's actually only one parameter allowed for a given argument. But we do some syntactical sugar and some compiler tricks to make it look a little bit more readable than versus doing partial application with functions that have parameters and then other functions that are popped into it. The only reason I bring it out is this. If you're used to C++ IntelliSense or C# IntelliSense, you're used to a parentheses that says parameter 1, comma, parameter 2, comma, returns integer. You can't do that here. You have to read from left to right, and every time you see an arrow goes to, that is either a parameter or at the very end, the result type. So I didn't want to waste people's time, but I think it's important if you start diving into F#, go slow with the IntelliSense to start and realize that it's actually my function takes in parameter 1, passes it to another invisible function with parameter 2, and then returns your integer. So one other thing, there's no such thing as subs, what do they call them, VB.NET? I don't remember, subs. You have to return something. So you can't have a function that returns nothing. You can't have a function that returns null. No null refs, we talked about this. So you might have a function, you think it's great, you think, oh, I'm just doing a side effect. I just want to write to the database and nothing comes back, so I don't care anything more. F# won't let you do it. You got to return something. It could be a status code, it can be this kind of code. There's actually some syntactical sugar to allow it to be a fake, nothing happened. But the point is, your functions have to return something. Also in the functional world, and I think this gets me in trouble with the C#, the older ones, old school ones especially, functions are like toilets. Like you talk to object-oriented people, and they design patterns, and we're building a firm foundation, and we're building skyscrapers to the sky. No, this is a toilet. Toilets work best if it's only one way. Water in, biomaterial in, water and dirty water out. So you can picture parameter 1 is clean water in, parameter 2 is biomaterial, and the result is dirty water. There's no coming back. There is no refs. We're not referring to anything that comes out. Your parameter 1 goes in, it's never coming out. And because of that, parameter 1 comes in, it's immutable. You can't change it. So you're thinking, well, I have a function, I alter 6 things, and I return them all. You know what you do? You build well, we're going to call them record types, you're going to call them classes, and you return that out, like hresult, right? You get a bunch of things in there. That's how you do it. It's, again, very limiting, but once you start working like this and you only think in one direction, another whole class of bugs go away. Your first class of bugs, no ref exceptions, they're gone. Now we have any kind of ref type, any kind of mutability exceptions, gone. And you can follow your code from the top to the bottom, left to right, and it's very, very easy to debug problems. Of course, we have problems in F#, but it's very easy to figure out where that problem is, just from those tenets. You're not chasing down a no ref 6 layers into a nested function type thing. So I've done some diatribing. Any questions about functions and how we declare them? If not, I'll show you how they run. I hit Alt-Enter. My function, we take a parameter 1, parameter 2 returns an int, and sure enough, that integer when you pass in 1 and 2 is 3. Someone earlier asked about the compiler hints. So there's certain, we're a .NET language, so we have this library, things like strings. Well, if I just pass this in as my string and call toUpper, the compiler is going to say, I don't know what that is. I can't figure out it. It's not an int. It's nothing that I know of that calls toUpper. So we add this syntax right here that says, okay, my string is now a string. That's what the colon's for. And now the compiler's happy.
We have one question about your function declarations here, sorry.
Sure, go.
They're wondering if that function that you declared that adds 2 values, is it not polymorphic? Can it take 2 values of any types, or is it just default int because that's the default?
This is the default. So if I wanted to make this a float, the easiest thing to do is times. No, I can't do it like this. Actually, let me do it. Let me try to answer it a couple ways. First, by just showing some code in action. So if I do this, right, it's going to say no way, Jose, right? Because you can't have a float and an integer living together. So you say, well, I really want this thing to do floats. Well, there's a couple ways you can do it. You can probably do it like this. I would do it like this, where I pass in a float, and since I have oh, 1 second. Oh, actually, F-sharp still surprises me sometimes. I'm running this. I've made parameter 2 a float. Anyone want to guess what parameter 1 is? Because it assumes you know what you're doing, and it assumes that you know that you can't add an int and a float together. And because you've already declared this, it's like tie goes to the runner in baseball. Okay, that's a float, so this has to be a float, so the result has to be a float too. You can also do something like, go ahead.
Is there a way to make it polymorphic? Like, so so my function could be called the same with 2 ints or with 2 floats?
Oh, you can use the type, yes. I'm not going to get into that tonight. One, because I don't know what I'm talking about when I really get into that, and I don't want to do a disservice to people who do. But yes, there is a way that you can declare it as a generic, and then generic could take any type. I'll try to make an argument that you don't want to use polymorphism in functional programming, but you know, because why do you use polymorphism, and how you can accomplish that with functions, or a function declaration type system is where I'm going to go with that. But be that as it may, does that answer your question, Ben? Is that good? It doesn't answer your question, but it's, yeah, you can do it. You use the type system. You can use generics. Anything else? Okay, so let's go to lists. Everyone loves lists. Here we have a list, and I'm declaring it, and it's a list down here at the bottom. You can see 0 through 9. That's, you know, we use dot notation if you want to declare things like that. And then you can use the dot notation. The C# people use the dot on the other side, I think, of the indexer, but you can see, you know, in reference to wherever what the index is on that list, I can pull it on out. Lists are immutable. Can't change them, can't make them longer, and you can't change any of the values in there. So that's going to, of course, resolve to false because 2 does not equal 4. You're not assigning 4. You can say, okay, I'm going to make a 10th item on that list, and I'm going to assign it the value 10. No, you're not, because you can't set the item on lists. Immutable. So we have these immutable lists. So if I want to add another one, like a number 10 on the index to that, how do I do it? Well, I have to use the list append function, where I pass in my current list, I pass in a new list with that value, and I get my new list out. And so now you can see it's 1 through 10. Now what happened to my list? It's still there in memory, right? And my new list is also now there in memory. It's got a copy. I know all you C++ people, oh my God, it's so inefficient. It's not. The compiler is fantastic. Probably underneath the scenes, unless you use mylist further on in your program, it's actually deallocated immediately. I mean, the compiler is that smart. But from a functional point of view, think immutability. You're going to make copies all over the place. But from a perf and point of view, F# is incredibly fast and it's incredibly efficient with the memory. But we don't try to do that on the higher level language level. We let the compiler folks do that. Any questions about lists? Now, some of you are mutable, and so you want mutation, so of course we have arrays. The array syntax is just the same thing as a list, but I put a pipe across each number, or you can add pipes, and then you can delineate each one 0, semicolon, 1, semicolon, etc. And then you can assign them using that assignment value. And my array 2 now, of course, will be the number 4 in index 2. Any questions about lists before we press on? In that case, let's go to control the flow. We allow imperative branching logic. We can use if statements. At the end, I'm going to try to convince you don't want to use if statements, but we can. So here's a function. And it's line 5. We've defined it or declared it as a get number type, passing a single parameter called my number. And then I do a check, and I say if the number modulus 2 is equal to 0, then I'm going to give you an even. If not, it's an odd. So if I look at the function signature, you can see my number takes in an int and returns a string. And if I run this, 6 is certainly an even number. So you can see how the if-then statement works. We have if, we have else if, everything else. Now, there's a bit of a controversy in the functional community, in the F# community in particular, about if this is idiomatic. And idiomatic, I think, stands for it's my way, so leave me alone. The language allows it. and it's actually pretty common in the docs and in the bigger repositories out there on GitHub. So I would say that it is idiomatic, but I don't like to use it. Instead, I use something called pattern matching and discriminated unions. And I don't remember my C++ well enough, but I assume that you have enumerations. Let's start with a basic enumeration as an example, and then we'll show you how discriminated unions really can make things cook well for you.
We do
Here
have
we have-
enumerations, but pattern matching specifically, I think, has been in proposal status for like 7 years now. I don't know
Oh, yeah?
if we'll ever get pattern matching.
Well, you talk about proposals. C++ is a fantastic language. I'm not sure you really need pattern matching, honestly. I mean, that's why it's probably, like C#, if there's a language feature out there, they're bolting it on. I mean, that's worse than Frankenstein's monster right now. I don't know if we have any C# fanboys on there. And, I'm an MVP, so I get to talk to language team. I'll tell Mads that all the time. Like, what other features you're going to steal from F# that try to bolt it in, doesn't look idiomatic, it's not syntactically correct until you finally do all this stuff no one's going to use anyway, and then he tells me to fuck off. So, no, he doesn't actually. We get along pretty well. But yeah, I don't see what I remember of C++. You wouldn't use it, but in a functional way, yeah, you use it all over the place because it's so powerful. It's a different way of thinking about how to control and flow your program.
Just as an aside, I'm sorry, but there are several people who are here in the room right now who very much lean towards functional and apply functional techniques to their C++ development. So
Awesome.
You're speaking to the right group in many ways for this kind of topic.
Well, it's great. Maybe next month we could do functional programming in C++. I would totally go to that, and I bet tons of the F# worldwide community would attend.
Yeah, whoever wants to volunteer to give that talk, it is not me. I will let them do that.
Okay. Well then, so yeah, part of it is, that's what I wanted to really accomplish is if you didn't think functionally, maybe think about your C++ code functionally and just use the basic tenets. Am I using mutability? Okay, knock it off. Am I using if-then statements to control? No, knock it off using enumerations. You can do a whole lot in C++, obviously, and you can turn that language into anything you really want. I wonder what the implementation of a pattern matching would look like. But okay, that's sort of sideways. I know we're running out. Oh my God, we're at 7. How much time do you really want me to spend? I have a lot more code. Do you want to see the real stuff, or do you want me to stay on the basic syntax?
I don't know. Let's let people speak up, I guess, about that. A couple of people just dropped off at 7 o'clock. I think the average person here is going to hang out. But speak up if you would like to. How fast do you want them to keep moving?
Yeah, I've started.
I want to see real stuff.
Real stuff? Okay.
Yeah.
All right, so this is a
All right,
function.
the only person to vote wins.
All right, there you go. This is a function. It takes in a number, returns back a pattern matching. This underscore means that it's everything left. So if I run something like this, yeah, I'm going to get the results back. So it's equivalent to an if-then on steroids. Type system, we have type systems. The most important thing to understand is that this is a tuple or tuple, depending on what part of the world you're in. The foo variable right here is defined, and obviously any part of the tuple can be any type you want. You just, when you build your collections, the tuples have to match in terms of types. This is equivalent to your classes. We have a person. I've defined a type, and this is the second keyword. We have a person type, and it has a first name, a last name, and an age, an integer. So person 1 is me, and I'm 50 years old. Thank you for rubbing it in. And we can serialize this. We go to JSON, everything else. But remember before, that basic tenet of functional. We don't allow nulls. What are we going to do with Madonna, who's 61 years old? I didn't give her a last name. What should I do? Last name equals null? Absolutely not. We use our type system. And I'll get to the real stuff in about 5 minutes, and I'll show you. Basically, I have a type system that says instead of the last name being a string, it's an option of a string. Think of it as an Amazon box. You open up the box. What's in there? Either there's going to be a last name, or there's going to be nothing. But I'm going to declare it ahead of time. An option choice. The option is either has a value of a generic, or it has none, some or none. So I run this, and then share here. Look at her last name. None. She doesn't have one, but she still compiles. And Kermit, he does have a frog. Look at the syntax. It says sum the frog. And so then I'd have to unbox this if I wanted to get the frog out and print it out or whatever. But that's what we use. We use a type system to wrap things. We don't use nulls. But that's the way, 99 times out of 100, that's the way we're handling our not conditions. Cool?
So we have to use sum if it's an optional thing?
Yes.
Okay.
Control the flow. So then we have our person again. First name, middle name is optional, and then there's the last name. So you can see right here is the formatted person name, where we get the person, get the formatted name, we pass in the person, we match their middle name, which might be either some or none. So for some of that type, I'm going to print it out and I'm going to add that person's last name. If there's no middle name, I'm not going to try to print it out. I'm not going to get a null ref. I'm just going to get what I want. So here's my person. I got my formatted name. Person 1, John Jacob Jingleheimer Smith. See the sum, and then in the none, I'm just printing out. Oh, I'm sorry. I should run the functions. John Jacob Jingleheimer Smith, comma John J, and then James Smith with no middle name. That's how we handle it. We don't check for nulls.
If John Jingleheimer Schmidt's name happened to have Unicode characters in it, would that be allowed?
Yeah, I think so.
Right.
I don't really know. I don't know what the standard output would handle. It's something we can do later. Cool?
Sure.
High order functions. This is where we get really funky. And so I'll slow down. I'm going to blow through the rest of it very quickly, but it's this. I have a function. It's called square. It takes an x and then multiplies it by itself. The signature takes an int, passes an int out. Cube. Taking an int and then multiply it 3 times and pass it out. Right? And then I have another function called sign where I pass it in modulus 0 and either, that shouldn't be positive or negative. That should be odd or even. Sorry, modulus is even. I should have just checked. I could do an if-then statement on the less than 0, but even and odd.
But the function is called sign.
So I guess I got to rename that sucker, don't I? What am I going to say?
Parity.
Huh?
Parity?
Parity? Like that? Like, we'll call it parity. Last person talks wins. So anyway, so these are 3 basic functions, pretty accessible to everyone. But here we go. I'm going to create another function. This function has 1 parameter. You know what that parameter is?
Is it
It's a function. Yep, that's why I called it F. It takes in a function, and then it takes the function and says the result of it is I'm going to take this function and pass in 5 to it. So what does a function signature have to be? Well, it has to take an int because I'm passing a 5 to it. And I don't know what the output is, Mr. Polymorphic guy. There's the output. It's generic. Tick A. Right? So pass 5 is here. So now I can pass 5 square, 25, pass 5 cube. I'm passing 5s to all those functions. So what is pass 5? It's a high-ordered function. That's a function that takes in another function. Do we use this all the frickin' time? So I won't go through it, but
so that tick A means it doesn't know what the result type is?
Correct. But once it starts resolving it and it finds a collision, it'll let you know. It's not like, it's not just a vat of memory that you can throw crap into. It's actually part of the type system. So further on, if you actually declared it and used it as a float, for example, I'm looking the wrong way, looked at the float, for example, it would then resolve back up and call it a float. Good?
Mm-hmm.
So now we have my list, remember, and now I'm going to square it with a function. And these higher functions are used all over the place. Here's the list library, or the list type. And it has a function called map. All you functional C++ programmers, you probably have in your code base everywhere map. If you're not as familiar with it, I wasn't. I was always doing imperative loops, doing counters, mutating variables on my list, for eaching, IEnumerable, all that garbage. List map says, no, I'm a higher order function. I'm going to take in a function, and I'm going to take in a list. And then for every item of that list, I'm going to apply that function and give you the resulting list, brand new list, right, immutability, but it's going to have the results of that function applied. So here's 0 to 9 and squared, so I can go ahead and use this pipe forward operator so I can put the my list over here, and then the square function, which I've defined up there, in, and I'm going to run it. And so I can run this, and you can see down there at the bottom, my squared list 2, bunch of lists with that initial list applied.
There's a comment from Connor here that that's the equivalent of the standard transform algorithm.
Okay, and that's pretty common in C++?
Let's let Connor speak as to whether or not that's common for people to use that in C++.
I would argue yes.
All right.
Okay.
So, and I know I'm talking fast to some people who maybe not are familiar. Let's talk afterwards over beers or whatever about this. But yeah, so what we do in functional, we start with our data, and then we start mapping the snot out of it. And there's other functions that we do with data, like filter and all these other things. Most common is obviously map, reduce. Hello, Hadoop, right? And I'll show you why at the end, because we can do parallels and like in a cinch because we have mutability. But anyway, so that's what we really do is we take our functions and we just bum, 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 and then we get our results. And so any step of the way, you put a breakpoint, you want to see what's going on, you put your, actually this resolves completely. So you might, any step of the way, break out what you're doing to see the results. But anyway, so here we go. We're gonna square it, we're gonna cube it, we're gonna assign it from my list, and it'll tell you if they're positive or negative coming out of the results. And I don't remember what the results are, so let's just square it. There's the results. Okay, let's square it and cube it. Okay, there's the results. Okay, now let's look at the signs. So that's maps and high order functions. Real quick then, some of us are lazy, like me. So instead of declaring functions explicitly, if we're only going to use them once, we use something called Lambdas, which are anonymous functions. We use a fun keyword here to declare Lambdas. So here's 0 through 9 again, and that's exactly the same thing as before of declaring that squared function. Piped out, same results. The fun keyword starts with a parameter list, and then whatever the body of the function is. Remember, we don't have return keywords and stuff like that. Go ahead.
I have another question here from John. How does map work if the types aren't known? Is map a generic, one of these generic functions?
It is. Map will figure it out for you. What it won't do, and I'll show you this in the real examples in about 10 seconds,
Sure.
is when you pipe, the output has to match the input, or the input has to match the output of the prior function. So what are you going to do if you have an integer, and now I'm returning a float and then a string? Well, there's actually a way around it. I'm going to show you that. But the generic part of it just sort of figures itself out.
Okay.
The A prime is okay, but the A's have to match or something like that?
Exactly.
Okay.
Oh, and you know, everyone likes Hadoop and big data, so that's map and reduce. And I really came to F# because I was doing data science work, and I was sick and tired of R, like, not giving me the type safety that I needed. And same with Python, really. So I started noodling around with F#, and that's what I started doing. It's a lot of maps, filters, and reduces. So, any questions about the syntax? 'Cause I heard that you're all itching for real stuff, and we're running out of time, so let me jump over. I still get 5 minutes back from my computer blowing up, so I thought I'd show you 3 examples to throw you through different concepts. Now, this is probably less important to you, this concept, but it really resonates with the C# people, and it's a concept called railroad-oriented programming. And the concept is this: you have 2 tracks. Track 1 is your happy path of your execution of your application. Track B, or the other rail, is when things go wrong, and they're running side by side. So remember, in functional programming, there's no turning around on your track. There's no, you can branch off, I guess, but you're going along like this. It's only one direction. Remember that, only one direction. So if things go bad, we don't throw exceptions and pop out. We just continue to the end, but we're no longer on the happy path, we're on the failure path. So how do you do that in practice? Well, here's my record type. We got a bunch of properties of that customer. If I serialize it over to C#, it'd obviously be a class with all those mutable, it would turn mutable on me, etc. Actually, it doesn't. You have to pass it in the constructor. But in any event, we got this customer. Now we have a type of result of T entity equaling success of T entity, failure of string. So here we go. I'm gonna define this for you. Let me run that. Come on, there we go. So result takes in a customer, takes in a car, takes in a float, takes in whatever, and then it returns either I was successful with this car, this customer, or I was a failure and with a type string, and I'll tell you why you failed. So these are the two rails on my railroad track, okay, on this type. This is our discriminated union. So now I'm going to come over here and I'm going to do some validation of the customer. Now, granted, this is a contrived example. I could do all this, back up with option types and everything else. But here we go. We have a function called last name's not blank. You're going to pass in a customer. And that is either going to say, you know what? You're either last name is blank, you're good, here's the customer back at you, or no, you failed, and here's the reason why.
So Madonna's not allowed to be a customer at this bank.
So right now, Madonna's last name would not, you're right, because it's a string, you could pass in string null. You're right, Madonna would not be a customer. She would fail the last name not blank. And then maybe, I don't know, who has a single letter last name. Whoever, you get the idea.
Iced tea.
Yeah, there you go. So here's where people get tripped up. There are 3 functions in here. The first is the bind function, which I declared, which passes in a function. In addition, I then declare an anonymous function that says, okay, whatever input that came in into my bind, I'm going to say, go ahead and apply the switch function if it's on the good path. If it's on the failure path, don't do anything. So effectively, you're going down the railroad tracks. Remember, we have our failure and our good. And then suddenly, we get to a function. Think of it as a gatehouse, a big black box. And in there, we say, you're okay, keep going. You're not okay, okay. You're already in the failure track. I'm not going to do anything with you. So I'm only going to apply the function on the good track. Okay? Are we okay with this?
I think so.
Okay.
So just if you're curious, we are getting comments in the group chat here with, let's see, Connor posted a link.
This is
to
a
the
monad.
Yeah, that's the monad, and there's a link to the C++ 20 equivalent of some of your examples.
Oh, great, great. I'd love to see it. So yeah, so it's the bind monad, but people get scared when we talk to monad. Well, maybe just a C#, use C++, or people are fine. But anyway, so now I create another function which is combining the last name and binding the greater than 2. So I have a single function to validate the customer. Oh, I forgot to send that to the REPL, sorry. We good? Yep. So now we have validate customer, you pass in the customer, you're gonna get a result of customer. And then we have a bunch of other code. This is a bunch of glue code where we're actually going to the database. And this is where, in the functional world, we don't do structured exception handling and throwing exceptions, because then you're off, you're going back against, your toilet's coming up. So we catch exceptions and we ignore them, basically, or we repurpose them from crap structured exception handling into beautiful one-way direction only, 2 tracks. One, you're either on the good path or the bad path. So there's the database call. This is then we email people. So in a typical business application, oh, and then I also, functional people love infix operators. They have the Elvis infix operator. They have the TIE Fighter infix operator. Here's another infix operator that basically is the same thing as bind, so it looks cooler when you write it. But so here we go. I'm going to register a new customer. I'm going to pass the customer. The first thing I'm going to do is validate them. And then if we're on the good track, we're going to insert them. And if we're still on the good track, we're going to send an email out that everything worked fine. So then I'm going to highlight all that. I don't think, where did I didn't highlight the secret connection. And the commented code out is just the actual, I mean, I literally lifted this from a system that we're using in production. So it's a lot of ADO garbage and stuff like that.
Did you define a new infix operator there? I missed that, sorry.
Yeah, an 86. That's the one I used.
So
There's
can you
a
define
common-
any series of
Sure.
tokens?
I think, what's the TIE Fighter one? That's a pipe, a boom, and a boom, and a boom. I think that's what it is. So that's the TIE Fighter infix
Okay.
operator, right? So I do that, and then I can TIE Fighter it to here.
Oh, we totally need that in C++.
Infix operators.
No,
Yeah,
no, no.
I
I mean being able to define our own operator.
How do you set the precedence and the associativity of user-defined operators?
Oh, yeah.
I'm sorry, I didn't. How do I assign the associativity of the operations?
Precedence. How do you set the precedence of your user-defined operator?
So the infix operator, you mean?
Yeah, yeah. So whatever that is,
Okay.
like if you had defined multiple operators like that and used them in one statement, what order is it going to evaluate them in?
Oh, yeah, I don't know. I've never thought about that.
At least in other ML-ish language except Haskell, it's decided by the first character.
Oh,
There you go then. First
Okay.
character.
I never use F#, so I don't know.
Yeah, I'm guessing if it's in Haskell, it's probably been adopted by the other functional languages. What's it in Scala? Is there a Scala person on the?
is there anyone who does Scala here?
I
met
hate
exactly-
Scala, but yeah, I did some Scala, but I hate it.
Well, anyway, let me press forward this example. We're now using the TIE Fighter operator, not the bind
Sure.
operator. But I have Jamie Dixon here. And let's do this. Let's say that I only have one letter last name. So I'm going to do this. And of course, it's going to fail because my last name is less than 2. And then you're going to say, okay, if that's valid, go ahead and run it. And sure enough, I get my success here. And then I would obviously handle that success with a pattern match. Did I get success? Okay, to the screen, yeah, you're inserted. If it failed, we actually use discriminated unions on different kinds of failures. So you might have a critical failure where you then launch into letting network operations and everyone important know, or you'll just get it, hey, you failed the validation error, just pass it up to the person on the screen that they have to make a longer last name or change their parent's name or something. But so, that cascades pretty quickly in the type system. And when we get to the next example, I'll show you that in action. I think you'll appreciate it. So any questions about, well, I'll call them monads, but any questions about how we chain functions together and how we use functions to change the shape? All right, then I'll rush on to domain-driven design. So C++ people, you obviously, well, I would think you guys are big into domain-driven design, Eric Evans, all that. Yes or no? Is that more a Java thing and a C# thing? I don't know enough about the C++ community.
I missed the question, I'm sorry.
Does anyone care about domain-driven design?
Domain-driven design. I've never heard those letters put together before. Tim cares about them, I think. Tim, speak up if you would like to.
Yeah, I do a lot. It provides some nice organizing principles for code and responsibilities.
Yeah, and so this is going to blow your head off if you have never thought about using a type system to enforce all your DDD. I'm going to make a statement here, and this usually gets me in trouble with the people who do business applications. You only need 2 types. Out of everything that's available to you, you only need 2 types: record types and option types. Record types, which we talked about, are AND data structures, first name and last name, and optional middle name. Then we have these option types that are OR, cat or dog, success or failure. That's the only types you need to do an entire domain-driven design patterns in production for large code bases. And this is, I'm using sort of a trivial example, but I think what I'd like you to do is maybe think mentally about how you would implement this in C++, how many classes you'd use, how you use polymorphism, inheritance, all that other stuff, just to model how would you do a baseball at bat. I'm not a big baseball fan, but I figure it's pretty accessible to everyone on the call, I hope. So I have a type, and this is ball chances. So if you're not familiar with the rules of baseball, the pitcher throws a ball, batter's sitting there, and the ball comes in and the umpire says it's either a strike or a ball. And if you go to 4 balls, you get a walk. If you go to 3 strikes, you strike out. So you're allowed 4 ball chances: ball 1, ball 2, ball 3, ball 4. I've only done 3 ball chances here because the ball 4 actually means something else. Strike chances: strike 1, strike 2, right there. Out chances: in an inning, one side's up, they get 3 chances, or they get 3 outs before they come off batting and they go out into the field and field things. Safe hit: if I hit the ball and it goes into play and I actually made a safe hit, I would either make a home run, a triple, a double, or a single. That's it. That's all I can get. But when I swing that bat, I might foul the ball off. And so then we have to keep counting our strike chances. I might hit the ball, it goes into play, but they get me out. Or I might swing and a miss. I might swing and a miss, and I'm out anyway. Or I might hit a safe hit, and if I hit a safe hit, it's going to be a single, double, triple, or home run. So I've just covered a lot because I know we're behind. Do people have questions about what I've done so far before I keep going? Okay. Well then, when I swing that bat, I'm either going to get a strike, I missed the ball, or I'm going to hit the ball and get that hit result. And then when I'm pitching, I'm either going to make a walk, I'm going to strike the batter out, I'm going to throw a ball, or they're going to swing the ball and then have a result of that swing result, which is either a strike or a hit. So on the pitch types, they can either throw a fastball, a curveball, a slider, or throw an intentional ball. So those are all discriminated unions. Then we have 3 record types to make our scenario complete. We have a ball club, which is the name of the New York Yankees, for example. And we have a player who's going to have they're going to be part of a single ball club at any point in time before they're traded, and their first and last name. And then they're going to have a pitch. And that pitch is going to be, we're going to have a pitcher of a type player. We're going to have a batter of a type player. We're going to have a pitch type of either a fastball, curveball, slider, or intentional ball. And we're going to have a pitch result of either a walk, a strikeout, a ball, or a swing. And then we have one more discriminated union of either being the home or the away of the ball club. So if you're not familiar, I might have not mentioned this, I'm from North Carolina. There's a great movie called Bull Durham about Durham Bulls. My family and I used to go to the Durham Bulls games. It's as good as advertised. But we have a ball club called the Durham Bulls. We also have another ball club called Yard Goats. Actually, they're the Fayetteville Generals in the movie. And then we have a pitcher. That pitcher's first name is Ebby, and his last name is LaRouche. And then we have a batter. And that batter is on the Yard Goats with the name of Bert Brooks. And Bert Brooks came up, and he was the batter. Ebby Calvin was the pitcher. Ebby threw a fastball, and Bert Brooks hit a home run. Look at this unboxing. He swung the ball, he hit it, it was a safe hit, and he hit a home run. If I run all this, you'll just see it compile and run. You can see it all compiles and it sort of all rolls out to you. The advantage of this is that you can never have a ball 5 because we don't have a variable that's mutable that can actually count to ball 5. We can't have a swing that's a hit that turns into an out. We can't have a swing with nothing happening like a null ref. It has to apply. So you get pretty deep in here into the woods. And so you build some accessibility functions to pull the things out that you need at a point in time in your program. But by modeling your domain with either records or discriminated unions and or types, and applying the sum total of completeness of what can happen in your domain, you're throwing away most of your unit tests, and you're throwing away most of the bugs that would be associated with mutability and null references. I also put in, there's another one, just to show an example, there's another movie called Major League with Charlie Sheen, where he's on the Cleveland Indians, and then there's the New York Yankees. Oh, and we can't have mutability, so of course we've already declared those things. So Ricky Vaughn is up on the bat, pitching, and then Clu Hayward's hitting the ball. And in 3 pitches, you can see he swung the ball, he swung at the ball, and he missed. One other really nice thing in F# is we have a convenience function or overload on the record type. So if the same thing happens again and we have 18 properties, well, I don't want to type 18 properties. Only one property changed. I'm going to say, okay, give me what you had before and change that one property. So there's a swing and a strike on strike 2. And then on the third one, the pitch results is straight out. So, it does allow a little bit of terseness because you don't have to keep typing and cutting and pasting or typing the values that don't change. So I think that's also why I wanted to throw it in there. Any questions about domain-driven design? And Tim, if you're on the phone, does this resonate at all with you? Or?
Yeah, in the sense of just using your type system to model the business domain and making impossible or unallowable states not representable.
That's exactly, I mean, you're probably borrowing words probably from, I don't know.
From Ben.
Yeah, it's making, if you cannot make illegal states, what is it, make illegal states irrepresentable? Like, make illegal states unrepresentable. I think that's the right way to say it.
Yeah. Right? I should point out that Yaron Minsky also, if you know that name, has done a bunch of talks and work in this area.
Is it in C++?
No, he does OCaml, I think, at Jane Street.
So I'm sure that this example, which I got from Scott Boschlin, who hangs out in the Isle of Wight in England, he's the big F# DDD guy. He probably saw those videos and applied it from it's probably natural from OCaml down to F#. All right, cool. All right, last one, and I wanted to leave you with like a real example. Well, I think these are pretty good examples to illustrate points. And I'm a half hour over. 10 minutes for a computer breakdown, so I'm 20 minutes into your beer, so I'm sorry.
Don't worry about it, at least from my perspective.
Okay, so thank you. And so this is it. I'd love to think that I'm like really cool data scientist running a team of really smart people, but we do a lot of glue code. You know, natural language processing by itself doesn't solve any problems. So inevitably we're part of a continuum. We're part of a computational pipeline. We're part of all this automation going on, you know, and we're one small piece, very important piece. But F# is fantastic at glue code. So I've just showed you like some domain design. I've showed you some railroad-oriented programming. I wanted to show you like, it's like kind of a cool example that sort of got me hooked on F#. So I'm running this in the REPL, and I'm pulling in some packages, some DLLs, F# data and parallel seek. And I'll talk about parallelism and why in functional programming, why parallelism is so easy when we need to use multiple cores. But anyway, we're opening those up. We have this concept of type providers. Remember, we can infer types. So that means I can open up any data source in the world and immediately get the type. So if there's a CSV out there with a bunch of ints, floats, and strings, I immediately can, and if there's a column at the top that tells me what they are, like as a data scientist, I love CSVs, that's what we live in. You know, first name, a bunch of data, last name, a bunch of data, state, you know, date of birth, integers. We can use a type provider. We just point to that CSV like this, and we suck in data. So here, let me go to C users. I'm going some crazy here. I'm going to my file system. I don't know if Windows can handle it. Yeah, so here's a CSV I downloaded from Yahoo Finance yesterday about Microsoft. And so you can see it's some basic stock price information. We have the date, the opening price, the high price, the low, the close, the adjusted close, and the volume for the day. Pretty typical data frame that you see. And there's 255 rows of data, so 255 days of trading on Microsoft stock. No, I don't want to change it. So I'm going to go this. I'm going to go and say, okay, type provider, go point to that file. And by the way, load that file. And then of all those things about the file, I don't care about the file name. I don't care about who created it. All I care about are the rows of data. So if I highlight the rows of data, you'll get row after row, now a type-safe way of dealing with your data. So like the date time of that, you know, the first column was the date time. That's a date time, so it's going to give you all the properties of date time. And then it has the open price, the close price, all this other stuff. And I should just do this. This is just the first row of the data. So it's a lot of date time, gobbledygook, and then the other values. So one of the cool things is, if I want to, I'm going to do this. I can explore this data. So I assign, this is actually 2 lines of code. Let me type it out for you because this is the cool part. So I have that rows of data like I talked about from that CSV. And I'm going to map. We already talked about map. And I'm going to say, okay, that's a function. I'm making an anonymous function. Of each row, what do I want about that row? You see, I didn't define any of that garbage ahead of time. It just inferred it from the first row. Now, there's other providers out there, like if you're using R and Python, that if you tell it, yeah, I'll figure this out. But tell me you get the dot notation and tell me if you get that type safety. The answer is no and no. So it's fantastic. I'm not using indexes. I'm dealing with my domain, and so I'm writing code that actually makes sense to me. So what I did is I said, okay, this is .NET code. I can use any .NET library, including anything that's Windows forms. I can use anything on mobile. I can do anything with this F# code. So let's run some charts. And sure enough, over on that screen, I'll bring it over here. There's Microsoft's charts using Windows WPF. So if it's in .NET, and most likely it is, you can use F#, hook up with those libraries, and go with what you need. This is a data science-y experiment. You know, I was just looking at some stock data. But let's say I want to build an application that I think is going to make me millions of dollars on the stock market. And I think one of the key indicators is if the stock is trading on volume greater than its average volume, then it's a buy. So I'm creating a function, and I'm taking the rows. Now, this is not passing as a parameter because it already knows it exists, but for reals, I pass it in up here as a row. But in any event, here's the average volume. I'm going to map. I just want the volume, and I want to make it a float. I want to take the average of it and return it as an int32. So on any given day, I can then say, okay, filter me on any given day where the close price is greater than the open, so it's an up day, where that volume was greater than the average volume, where the days of the week is a Friday, because maybe I think Fridays are hot days. And then I want to sort it by descending, and I want the last three. And then I'm going to take the average of that open price, and that's my magic number. I'm going to run all that. So the magic buy price right now is $181.46. You're thinking, okay, that's pretty cool. So I built something, I could then throw a UI on it, I could throw a mobile app on it, deploy it to my iPhone using Xamarin, it's F# code, everything works fine. Here's the thing that I think might get some C++ developers excited, is I'm going to open up this library called Parallel C. Rows is immutable. I don't have to worry about if there's a lock on a mutable variable when I try to send it to a different processor or across the wire to a different machine, which is one of the reasons I think functional programming became so big with map and reduce when they were trying to distribute the workloads. So here's a parallel magic buy price with the rows. Look at the syntax change. How many mutexes did I write? How many race conditions will I ever have? I just type pseek, I open up parallel seek, and I'm parallelizing. So, and there's also other ways to do async programming. It's not as elegant as the parallelism, so I didn't want to show it because I'm trying to hype up F#. But for me, when I had that, and I actually had a medium, I never really had a big data problem, but I've had a medium data problem. And then we just parallelized it with machines, and we passed out the function to those machines and got the results back. It was really elegant. And the cool thing is it was F#, we just immediately integrated with the C# stuff that was already there. So I've talked fast for the last 46 minutes. If people have questions, I'll do my best to answer them. If I don't know, I'll be 100% honest and say I don't know, and let's find it out together. I hope that gave you a flavor of F#. I thought that it could give you some ideas of some things you can do with it. I hope that you write functionally in your next C++ program. And if there's any questions for Roundup, thank you for your time.
Thanks a lot, Jamie. Yeah, let's, like you said, open it up for anyone who has questions.
I have, thanks for the presentation. I have a question. I spend a lot of time doing surface level learning of different programming languages, and of the ML family, F# would actually probably be lower on the list for me to learn, and that's primarily driven by the lack of documentation. Or from what it seems to me, like I was in a different meetup, and the person wasn't able completely to speak to it, but they said that like Microsoft was in the midst of like transitioning, and that some doc links were broken. Like, are you able to speak to like the amount of effort that like Microsoft is putting in to like F# documentation? Because half the times when I go to like one of these seek dot filter or like, you know, whatever the documentation, like most languages have pretty good docs for that, but half the time the Microsoft MSDN docs are like broken, and like the Stack Overflow ability or Google ability of these operations, it's like, it's really hard to track down what the algorithm name is in F# that is like the equivalent in others. Are you able to like, is that an issue that the F# community faces, or?
Well, I think so. You know, Microsoft started F# and they included it in Visual Studio, and it had a very hard landing. It was, you know, you can't, a majority of the C# developers out there weren't interested in learning a new language, and they're not the kind of people that were really interested in learning a language for language sake. So, you know, Don Syme, who wrote the language, said it had a hard landing. So his first effort was actually to pull it out of Microsoft. So, you know, it's 100% open source, and it's now part of the F# Foundation. And so, yeah, it is just a collection of volunteers passionate volunteers around the world who are trying to contribute, and they all have their different agendas, and they only have a certain amount of time. It's not a broadly used language by any stretch. And so, yeah, the first place that you can see that manifested is the lack of documentation, and it's not really on Microsoft to update it. If you actually look at the numbers, F# shouldn't have any software engineers working on it at Microsoft. In fact, they have 2. And F# shouldn't have any project managers or program managers on it. In fact, they have a full-time one on it. I mean, if you look at VB.NET, the language, it still gets more file news tomorrow morning than F#, yet there's no project manager or program manager on it anymore. There's a part-time one they put on, whenever there's a build or a conference, but that's it. And they have no dedicated engineering support. So Microsoft has a disproportionate amount of resources behind it, but it's still not enough. And the worldwide community is a small, vocal community that does their best, but you're right. Looking at the docs without actually going to Stack Overflow can be problematic. And I've run into the same problem. I think that was Connor. I will tell you this though, if you join the F# Foundation and get on their Slack channel, and they don't even really, a lot of them don't even bother with Stack Overflow, though they do monitor Stack Overflow. And you pipe in a question, you'll probably get an answer within an hour. I mean, that's usually my cadence. So it's a very welcoming community, to be sure. It's a very knowledgeable community. And I think the thing I like about it, coming in as a complete rookie, is that they're very non-judgmental about your skill set. So I would encourage you, if you were interested in it, you'll make your own choices about learning ML, but I would say that my first step would to encourage you to join the F# Foundation, get into this, into Slack where they are, and ask some of those questions. If you're someone who loves computer languages, it sounds like you're someone who is, you'll find the subgroup that'll be right on your level with peers of your ability and knowledge, and they'll answer your questions pretty quickly. So, I wouldn't let the lack of documentation stop you, but it's certainly I think it's a friction point, and it is a barrier for adoption.
Thanks for the answer. That's good advice.
Yep.
We have a question from Brian, if there's any particular problems that are or not well suited for F#. My first thought, so where my background is you wouldn't use it for UI development, UX development, certainly in the web. But they have these great, trans compilers, just like, what's the one that C# uses now? Blazor. So they have it, you write your C#, it turns into JavaScript magic. And you do your HTML, I guess it somehow magically comes out of WinForms or something, I'm not sure. So I would say UI development, but saying that, last year I was involved on a side project with a startup, and we wrote a Xamarin application for targeting iOS and Android in F#. And the reason we used it was a .NET shop. It was that the Xamarin support was finally prime time, so it could support sort of the different scenarios. And we did a lot of domain-driven design in it. It was, quite frankly, a lot of fun to work on. Unfortunately, that startup never really got traction, so I still have my day job. So that scenario, I would not look at it. Also, I'm sure anything I write in F# you and C++ can write faster. So if perf is a really big issue, you're going to stick with C++. So you have no problem just matching F# and C# as it makes sense for the particular problem you're trying to solve.
I used to say that. Now I just say, C#. It's like me looking at Java code. I actually have a project next week in Java. I don't know. It's one of those things that you look at the way they wrote the code and you're like, if you just use a pattern match, you wouldn't have these 3 bugs. But that's where the money is. I mean, there's plenty of jobs. I mean, it's not like C++ developers you guys are hurting, I wouldn't think, for business. And same with C# and Java. So I'll apply my trade there.
Any other questions? I'm curious who wants to give oh, go ahead, Ben.
I had a question. So F# has built-in partial application. Did I get that right from earlier? Does that mean that it supports a point-free style for function declarations?
I don't know. We want to look at it right now? Let's look at it later, okay? I'll take that as a to-do. I don't know.
I'm curious who wants to speak next month and say, give some of these examples and show what they would look like in C++. From the
Can't wait to come to it.
If anyone wants to speak up, go ahead. Otherwise, I'll just come up with something random to talk about.
You should do a coding dojo where you can't use if-then statements, or inheritance, or polymorphism. No mutability either. One of the things the F# people love to do is code golf. Are you familiar?
Yes.
Yeah, and so obviously the language lends itself to winning code golf. but then you get, like, it gets cryptic so quickly. You use all these infix operators and stuff, and it turns into a single line of garbage, but it compiles, it runs. All right.
When you say no polymorphism, do you mean runtime polymorphism specifically?
I would think design time too, right? Like, you know,
Because I think
circle and a square is a type of shape. Don't do that.
right. So ad hoc polymorphism, but not parametric polymorphism, because we're using a whole lot of parametric polymorphism in F# and indeed in C++.
Okay, yeah, thank you. Yes, that's important qualification. Yep.
Yeah, polymorphism is a highly
Polymorphic word.
yes, that like only gets taught one definition in university, and that's the runtime one. And I remember the first time in an interview, I got a question, what's static polymorphism? And I was like, templates? And they were like, yep.
Really? Oh, good job.
That was a good guess. But at the time,
No, you can have polymorphism. All you can let you have inheritance. You just can't use if-thens. You can't have mutability. And oh, how about this? No nulls either.
Sounds good, actually. I think there's a few of us here who aim for that's pretty much what you just described.
And no const expert, just to be difficult.
Hey, no.
You need a constructor. I mean, without mutability, how are you going to assign anything? It has to be the constructor, right?
Yeah.
You can do a lot of things in just templates.
Yes, you can. You can technically do anything with just templates, but you don't want to.
But since you can build lambda calculus on templates, that means you can build anything on templates, basically. But
Yeah.
it's useless.
Professor Church would like it.
Okay, I feel like we're officially at the end of the actual talk and Q&A session at this point. I could be wrong, but just wanted to thank you again, Jamie.